Welcome, everyone, to Python Packaging Simplified by Asheesh Laroia.
Thanks. Hi, everyone. Wow. Hi, everyone. Hi, great. So I'm here to talk about Python Packaging Simplified. And as this title slide suggests, I'll provide information useful to end users, app developers, open source contributors. This talk is focused mostly on people who aren't the one packaging things. There will be a talk after this in more depth. I can talk about that at the end also. There's also a couple of micro changes that you mostly don't care about. Sometimes in the description, I promised that I would tell you how to debug complicated conflicts between Debian installed packages and pip installed packages. If people really want to know that, you can ask me in the questions. There wasn't time to fit it in and do it justice. So with that said, I will explain to you the goals of this talk. I want everyone who attends this talk to be able to install Python code on their own system without needing to use root privileges or admin privileges or sudo. I also want to have a basic understanding of how to distribute Python code that you've written. And then I also want you to know how to learn more, because there isn't time to do justice to everything in Python packaging land. So it's helpful if you know the basics and what are the right questions to ask, and then you can do the right research to find out the answers. So let's talk about installing Python code. If you have a Python interpreter, it might look something like this. And if you're lucky, your Python interpreter comes with batteries included. One of those modules is the numbers module. Anyone in here imported the numbers module ever? Yeah, I just found the name of it in the Python standard library. It sounded cool. So when you import it anyway, it gives you a thing you can print. And if you print the numbers module, like any module, it'll print the path that it came from. This is one of the most important things to know about Python packaging, that the module object will tell you where it came from if you let it tell you. This can be super useful in debugging. And it's driven by a list of directories that are searched when you import. And that list is in the sys module, sys.path. It's a list. It looks something like this. This is kind of long, but the numbers module definitely came from one of these entries. And the purpose, again, of sys.path is so that the Python interpreter will search in each of these places for a module or something it can import until it satisfies your request. So I'll highlight the second one here. This path, userlib python 2.7, is in fact where the numbers module came from. So that's great if you want to use Python code that comes in the standard library. But you might want to install things that aren't in the standard library. For example, if it's around the time of Hurricane Sandy, and you've been reading this website, Regretzy, you might know that these cookies are a Hurricane Sandy special that you might want to buy. They're handmade, available for you on Etsy. And so if you're lucky, you can import an Etsy module by doing something like this. The photo here is a snapshot from the cheese shop sketch, because that is where you can find Python code to install. The website's name is cheese shop, although its domain is spelled pypi.python.org. I think there's some history about it being used to be called the cheese shop, and so now it's still called the cheese shop, but nobody says it except in recorded talks at PyCon. But if you search there, if you search on the cheese shop for Etsy wrapper, because you want to find something that will wrap the Etsy API, then you put in that search, you'll find a web page that looks like this. This is an index of packages matching Etsy wrapper. I'll zoom in just about where the mouse pointer is on this first hit, python-etsy. So great, there's some code on the cheese shop that will let you communicate with the Etsy API. This is sweet, but it says python-etsy is the name of the package. Some of you might have already noticed that if you try to import something called python-etsy, you would get a syntax error. This doesn't make sense. How can the thing be called python-etsy? You can't put a hyphen in a module name. So the name of things on the cheese shop is not the module you're installing. It's the so-called distribution that happens to contain some modules. And who knows what modules it contains? Luckily, this one explains on a cheese shop entry, which you can see here. This is just the python-etsy page on pypi.python.org. And it says, great, it'll make it easy to interact with the Etsy API. There's information on how to install it. And in the initialization section down below, it tells you that it'll make a module called Etsy. So great. If you have this, you can import Etsy. Some of you astute readers might have noticed that the installation instructions say sudo pip install etc, and the more astute will have noticed it says sudp. Pip install etc. So this is a photo of a guy named Genki Sudo. He's part of a band called World Order. They make fantastic robot-esque choreographed dance moves and the music to back it up. I recommend finding some of their videos. The point is, this is what you should be thinking of when you think of sudo. You should not be thinking sudo pip install. Because sudo is an extremely powerful way to run any command. The results of it are sort of unrecoverable for your system. Something you run on a Mac or a Linux system with sudo can totally replace your operating system. And if you're on Windows, it'll give you command not found. So this is suboptimal. Also, I want to take a brief digression to say how I first got really involved in programming in Python. In 2001, I wanted to write some code to convert the high school newspaper's PageMaker 6.5 multi-page printed monthly newspaper and generate an HTML website, because the web is going to be the future. And I knew that Python was a great language to write programs in. I'd been learning C++ in high school. But the computer in the trapezoid office, that was the high school newspaper, I didn't have admin privileges on it. Luckily, as a teenage script kiddie, this wasn't a big deal. I downloaded a local privilege escalation vulnerability so that I could get a CMD prompt running as the quasi-admin username system so that I could install Python 2.2 or something. People don't always have sudo, so if you tell them to run sudo and they can't, that's kind of sad. Luckily, there is a way to install Python packages without needing sudo, and I'll bring you back to sys.path. In particular, one of the entries in sys.path is inside your home directory, or your users directory on macOS, or the users folder, or documents and settings, depending on what version of Windows you're on. There's a place that Python has that it will look if you install things in the right way. And there is a right way, and that way is this: pip install --user python-etc, and that'll take this python-etc thing, look it up on PyPI. It'll download the source distribution from PyPI. It'll succeed, and it'll clean up. I don't know why it prints cleaning up. I guess it removes the temporary directories. So after you do this, you'll be able to import etc, and when you do that, that etc module will tell you that it came from inside your home directory. So things look great. I want to pause for a moment to reflect. We've seen modules, like the etc module. We've seen distributions, which are what you get from PyPI. And we've seen tools. We've just seen one tool, pip install --user. We haven't talked about any useful reason to use sudo yet. We haven't talked about virtualenv yet, and that's fine for now. So pip and PyPI don't always work the way you want. And so I'm going to talk about a few of the failure modes. There is, by the way, a brand of ice cream in India called Quality, spelled this way. Actually, they stopped being allowed to be called ice cream because they fatten the milk with vegetable fat. So they're now Quality frozen desserts. But anyway, if you pip install --user etc, which is a different distribution than python-etc, so it's a totally different thing made by some totally unrelated people. It happens to also create a module called etc after you install it. Pip will give you this helpful error message. And the reason it gives you the specific helpful error message is that the author of this distribution uses a README file which has a square bracket in an inopportune place. And the square bracket means that pip, not knowing what to do, it'll look through the README for links, hoping that it can find a place to download the source code from. And it'll follow one of these links, and it has a square bracket. So it's like, oh, this is definitely an IP version 6 URL. And then it's not an IP version 6 URL, and then pip exits. So one problem with PyPI is that sometimes download URLs are wrong or they are missing. And in fact, there's no automated checking that when you try to pip install something from PyPI, that it'll actually install. Luckily, the first of these is fixed with pip 1.5. Pip 1.5 and going forward will only install if you pip install a thing. It'll look for that distribution, only look for tar.gz or zip files hosted on the Python package index, on the cheese shop. So that's fixed. Nothing does check, though, that things will actually install. It's just it'll only look on the cheese shop. Another situation you might find yourself running into, this is a bit obscure, is if, let's say you're installing some Python code and it's incompatible with your version of Python. Python 3.2 and Jinja 2 don't get along. 3.3 plus, great. 2.7, great. not 3.2. But you might try to install it, not knowing any better, and pip, not knowing any better, will try to install it. Pip will run into this syntax error, because this doesn't work with your version of Python, and it'll say, great, I've successfully installed Jinja 2, I put it in the right place, I've removed all the temporary files. So you're like, OK, well, I saw some stuff scroll by. What if I import it? And your Python interpreter will be like, what are you talking about? This can't run. So at this point, it might be worth thinking about uninstallation. So if you want to uninstall something, let's say you installed this module called Etsy, and you try to uninstall it, pip might tell you, there's no requirement called Etsy. That's because pip calls distributions requirements. And so there's no distribution installed called Etsy, because the Etsy module came in from the python-etsy distribution. So OK, we can uninstall things with pip uninstall. And this, by the way, is a huge improvement from the past. There used to not be any uninstall from stuff from PyPI. So this is actually pretty good. And the uninstall process is driven through this thing in Python known as eggs. So there's a data directory that contains information about this package, or I should say the distribution, the name of the distribution, plus some stuff, .egginfo. And inside the file package data is information about this particular distribution. Actually, this is getting renamed. It's going to be called distinfo, not egginfo, but that's not that important. Inside this file is information from PyPI, actually not from PyPI. I'll come to that in a second. It's information about the distribution, anyway. And the way this gets filled in, this directory, I should say, also contains information about what files were added. So that way, pip can use that to drive the uninstallation process. And there's no reverse index. So if you've installed a module, pip doesn't really know where it came from. But it can go from the name of the distribution to the list of files and then go delete them all. Anyway, this directory gets generated because pip runs the setup.py command hanging out inside the tar.gz that you downloaded with this argument egg_info, and that generates all this metadata. And I mean it runs setup.py. This is an important point. Setup.py isn't a configuration file. It's a Python program. It happens to contain configuration about how a Python distribution should be installed. And so a common failure mode people have is they want to not repeat themselves. So they say, I'm going to store the version number of this code inside the code. And then in the setup.py, they import the project. But this means that anyone else, when they run the setup.py, because they don't have the thing imported yet, it breaks in half. There's a lot of ways that setup.py programs can trip you up. Keep in mind they're actually programs. So this stuff so far works great so long as you have pip. But if you don't have pip, well, we should talk about how to get it. So if this is like your life, because you just installed an Ubuntu machine or something, then you'll need to download it somehow. And according to the pip website, the best way to do that is to download the file getpip.py and run that program. Only knowing what I've said before, you should probably add -- user to that. And if you do that, then great, pip will get installed, and you won't be able to find it in your shell path. That's OK, because you can add it to your shell path. And how to do this varies between shells. It varies between Linux distributions and Mac OS and Windows. But you'll need to add something like this. This directory is the analog of that directory in your home folder. This is where scripts or programs that are Python programs will be installed. So once you've added that to your shell's search path, you'll get pip. Great. So let's talk about how to distribute code. And I want to take a bit of an example. So we've talked about Etsy. We've talked about shopping after Hurricane Sandy. I have this sweatshirt here, and I can see it's kind of falling apart. It does have this cool octopus on it, though, which is holding a boat. And I want another one of these. So I'm going to write a program, maybe to buy one of these every year. If I just automate this, then I'll never forget. And we'll call it getOctopi, the name of the project. But because we're allowed some inconsistency, we'll make a Python program called octopi_getter. Rather, the Python module will be called octopi_getter. And I'm hacking, and this goes great. Some time passes, and I've read somewhere that I need a setup.py and a license in order to make this a real open source project. So I've added those. And now it's time to register it with the Python package index. So other people, other octopus sweatshirt enthusiasts, can find this on the Python package index. To do that, you run the register command, which prints some stuff and succeeds. So great. And then, if you need to upload this code to the Python package index, you have to run these two commands at once it won't work to run them separately. But if you do, then it'll create a source distribution, which will be named after the directory. Actually, it'll be named after some stuff in the setup.py. I'll come to that in a second. And then it'll upload that to PyPI, so it'll do some things, it'll print some things, and it'll succeed. So great. That works so long as you know what to put in your setup.py file. Here is the simplest one that'll work for the project I've described. The project is called getOctopi, so it'll be available on the cheese shop under the name getOctopi, version 1.0, why not? And it has this one package, octopigetter. But actually, some of you may know there's a difference in core Python land between modules and packages. And this is a one-file Python module, so you have to spell it this way, pymodules. I don't know why. It'll probably be, maybe that'll change someday. We should talk about that, and maybe we can fix that as sprints. Also, this is a Python program, so it's kind of weird that if you just run this thing, it'll print some stuff out. Normally with Python programs, the way that people structure them is they add a little protection so that it only runs intentionally if you run it as Python space the program name. If you were to try to import setup, the way we had it before, it would execute the setup.py call, which is weird. I think most setup.py files should be written this way, but people just don't do that. They just leave out the if name equals main thing, so great, we'll just write them the standard way. Also, by the way, disutils.core comes from around Python 1.5. And even in the modern documentation, you can see remarks about how disutils is great, and in Python 1.6, things will be totally better in disutils. And you can see that in the current version of the Python 3 documentation, not just the 2.7 stuff. So anyway, maybe I should submit a patch for that. So I think I'm signing myself up for some work at sprints. So you can add some more information to this. I can talk about myself. More importantly, I should write a summary and a description of this particular distribution that I'm uploading to PyPI. I'll tell you how to find information about that later. Long story short, you add all that stuff to the setup.py call using keyword arguments. So this is great. I now have a thing on PyPI called getOctopi. It has a module called octopigetter. The only thing it doesn't have is a program to actually get the sweatshirts. And eventually, I might write that. I might call it main. Here's what it might look like. But what I would really want is a way to run that from the command line, which is a bit odd, because Python is sort of really about importing things and running them inside Python. Luckily, there is a way to make these little command line scripts using setup.py files, and it is using the entry points keyword argument to the setup function. This is a really interestingly complex line. There's a key on the outside. There's a key in the inside console scripts. And then there's a key value pair stored inside a string. But that's just how it is, so that's just how you have to do it. So once you've done that, you can run pip install --user dot, which means whatever directory I'm in, find a setup.py file there, and execute it. And that will put the getNow program into your path. So you might run it this way, and I'll just show you an octopus here for good measure. So if you just run this in your shell after running pip install --user dot, probably what you'll get is command not found because you need to fix your path. So once you fix your path and you try again, you'll get getNow. It'll log you into Etsy maybe. It'll search for the kinds of things you want to buy. If you've configured it properly, it'll buy them and tell you how much you spent. Perfect. Anyone on the internet can now automate their acquisition process. So you upload this to PyPI again, and if somebody else re-downloads it, what they're likely to see when they run it is an error message. So we should probably talk about dependencies. On your system, you have an Etsy module because you installed it using pip install --user python-etsy. On their system, they don't. So we'll go back to the setup.py file, going from this to add one more keyword argument, install requires. And this here is the name of a distribution that your distribution depends on. So there are other ways to specify dependencies, and I'll just mention them very briefly. There's a well-known one named zc.buildout. There's another well-known one named requirements.txt. zc.buildout is really good for setting up not just stating how to install this particular Python distribution, but for describing the state of an application, including random files you download off the internet and need to put into the right place, and so on. Requirements.txt is a good way to list the specific distributions that you have installed at any given moment that you really think your application works with. And then you can pass that to pip in a way that I can talk about later. So this is all good. We can now upload things to PyPI. We can distribute them in a way that other people know about and can install based on the dependencies set correctly. Let's talk a bit about this development workflow. So the way I mentioned it, you run this command after you make any changes to your setup.py. And what this does is it copies all of your code into your local side packages directory, which means that if you make any modifications inside the directory you're in, you have to go run pip install --user dot again for them to show up. That's a bit annoying. So if we instead add the --editable flag to pip install, then it'll actually use the modules from right here. Rather than copying them into your side packages directory, it'll link them. So this is super useful. By the way, this has an old name, which is setup.py develop. I, having tried both of these, can now say pip install --user --editable is totally better. So just always use that. Don't use setup.py develop. If you mentioned other people in your development environment instructions to use setup.py develop, go fix that. So you might have also seen there's a few different places that provide a setup function. We've talked about disutils.core, but there's this thing called setup tools. There's this thing called distribute. What are those? Which one should you use? So distribute is an old fork of setup tools that is now merged back into setup tools. So don't use that. And in that case, you have these two choices. You can either use the one that comes with the Python distribution, disutils.core, or you can use the one that sort of seems cooler and has more features called setup tools. Doesn't really matter that much to me. Just don't use distribute. But also, I recommend using disutils.core, since that way anyone who runs your Python code in the setup.py is guaranteed to have the requirements needed to execute that setup.py file. So if you're going along, you might discover that the python-etc version that you need, the python-etc module had a bug in version 0.1.0. So you know that they upgraded it, they fixed the bug. You might need to specify versioned dependencies like this. And if your code that relies on this python-etc distribution, the newer version, conflicts with some stuff you already had installed that relies on the older version, you're going to have a bad time. So there is a tool for separating these out, and it is called virtualenv. Virtualenv is a way to separate out the Python packages that are installed so that you can get a fresh, empty Python for better or for worse. Hopefully for better, because it means that you have total control over what's in there. And then once you've done this source bin activate step, which will add these parens to your path, to your shell prompt, rather, the parens indicate what the name of this virtualenv is, which it sort of guesses based on what directory the virtualenv is in. You can run the usual pip install commands to make your code available inside this virtualenv. There is, by the way, a shortcut for pip install --editable. It is -e. If you do things this way, maybe I'll drink some water. If you do things this way, you're probably going to have a good life. So long as you don't pass --user to pip install inside a virtualenv, because then it will print you this obscure error message, and you just have to not pass --user inside a virtualenv. OK. Another gotcha with virtualenvs is, let's say you're hacking along in one terminal, your virtualenv is activated, so if you run Python inside this terminal, it'll only use the stuff from your virtualenv. And then if you open a new terminal window, the virtualenv won't be activated, and now you have to reactivate it or get totally confused. So I think that the activate script is kind of confusing. You can use virtualenv without using the activate script at all by just calling the particular copy of Python that it puts in that directory. The virtualenv tool will create a bin directory. Inside that will be bin/python. You can just write bin/python every time, and then you'll never have to have this confusion. Another problem you might run into is if you need to install not just pure Python code, but Python code with some C dependencies. How many people have seen an error message like this? Yeah, now we're getting somewhere. So if you don't have a C compiler, nothing tells you exactly what you need to do here. It's just like, so what I would do is I would install this LXML module from the Ubuntu or the Debian package, because those Ubuntu and Debian people are good at compiling stuff. I'm not that good at compiling stuff. Actually, I'm a Debian developer, but you might not be as good at compiling stuff as I am. So in that case, you might apt-get install Python, and it'll be great. You can import LXML, it'll be right there. And if you try to pip install LXML, it will actually satisfactorily say, LXML is already there, I'm not going to try. And it's good if it doesn't try, because if it did, it might fail. But if you do this in a virtualenv, you won't have the system LXML available, so it'll be like, nope. And if you really need to compile LXML or another Python package that has C dependencies, then you can use this Debian functionality to get the particular bits of code onto your system needed to compile the Debian package called python-lxml. This is kind of a way to abuse the Debian packaging system, also useful in Ubuntu, because what you're going to do is not actually build the official Debian package. You're just going to use this to build a different version of the same Python code, but you'll have all the stuff you need in order to do that. So when faced with these sorts of problems, a lot of people think, I know, I'll use Vagrant. So let's talk about that. Vagrant is a great virtualization system. It takes like half a gigabyte of space. You need to have Vagrant. You need to have a virtual machine tool like VirtualBox. You need to download some sort of Ubuntu or Debian image. And when you do that on the hotel Wi-Fi a day and a half ago for me, you know that you're in for an hour-and-a-half long wait. And then, if things go well, you can type this command, vagrant provision. Vagrant will then look for a file called vagrant file. It'll look for all the steps in there needed to turn this instruction set into a working virtual machine image that's running on your computer. Because as far as I can tell, macOS people find it hard to install software, so they have to install a full virtual Linux distribution in order to install software. Once you run this command, then Vagrant will run whatever provisioning tool you've configured inside your Vagrant file. So that means waiting some time for Puppet or Chef or Ansible or shell scripts or makefiles or who knows what to build your VM. And if that works out, it'll be great. You just took a long time, though. So let's think about things from a different perspective. If you're this guy and you're staring out into the distance, knowing that if things do not happen fast enough, horrifying things will occur. If you have new engineers at your company and you want to give them a good time when they first hack on your code, or if you have new open source contributors to your open source project, or you just want to have a speedier life, you might want to think about other ways to handle these sorts of problems. So I'm going to tell you about the ways that the OpenHatch project, which is an open source web app for helping, fittingly, new contributors find open source projects to work on, handles this. So we have a setup that allows us to go from nothing, just a Python interpreter on your computer, to a full running Django app in 5 minutes. And we do that without virtualenv, we do it without pip install, we do it without a C compiler. We use the database that's bundled with Python, which is SQLite, and I guess I didn't say it, but we don't use sudo either. Unfortunately, Django actually sort of requires some compiled code. It requires the Python imaging library modules if you're going to use certain functionality. So you might think that you can just import image, but unfortunately, image is not bundled with the Python interpreter. So that's fine. You might add an except to the import. And what we do is we do this crazy hack where we take a totally random, unrelated module, and we stick it in sys.module. So that way, if you import image, you will totally get something. What you're getting is an outright lie. But this is important because the Django image field will otherwise fail to initialize your Django web app when you do manage py run server. It'll be like, no, your models don't validate. And the new person will be like, does that mean I need a C compiler? Why do I need a C compiler to make a web app? Don't understand. So we also have some tricks in the test suite. The file I showed you is in a module called base/depends.py. So then we can check if base.depends.image is none. And if so, then we skip this test. I mentioned we do this all without virtualenv. So what we do is we just use pip to install all of our dependencies into a directory called vendor. And then we modify sys.path, which is that directory of places Python will go search for things, to include all the subdirectories that we've added inside the vendor directory. And if you want to learn more about this, we're using a trick created by the Mozilla Kitsune project. So, it wasn't our idea. You can search for that here. Finally, in terms of the Django settings to make sure that the databases don't require complex setup, we use SQLite as the default database. We do have an environment variable that you can set so that if you want to use the database we use in production, which in our case is MySQL, we keep that information in a different dictionary in the settings file. and then we dispatch based on the value of this environment variable. So that's all good in theory, but we want to know that it really works in practice. And to know that, we have an automated bot check our install instructions every day. And this is that bot talking in IRC, telling us, to our relief, that things will work if a new contributor shows up. And also, it takes about 2 minutes, 51 seconds. So if you're a human and you type slower than a bot, I think it's fair to say that it'll take about 5 minutes. So that's good. That's how we make the new contributor setup process for one Django-based web app really easy. You can apply some similar tactics to your apps. One other thing I'll say is that this bot helps us know that all of our dependencies actually work against the version of the website that we bundle, that we want people to use. So a common problem, as I mentioned before, is people require one version of something in the dependencies files, but then happen to have something else installed in their own machines, so they don't find out that it would fail for a new contributor. And when I say they, I mean we. We failed our new contributors this way, so I want to not fail them anymore. The robots check it so the humans don't have to. There's at least one other topic I want to discuss. So some Python modules are pretty slow to install. Twisted is one that takes about 41 seconds on my laptop a few days ago. That's partly because it compiles a bunch of stuff. Wouldn't it be great if the second time you installed it, pip just knew, oh yeah, I already downloaded that, I already compiled the C code, I'm just going to store it all and copy it into place. And it can do that now, thanks to this cool thing called wheels, which are a way to take the result of the setup.py build process, snapshot it, and then whenever you redo the install process, just unpack that wheel into place. It requires setting these complicated environment variables. There is a right way to set them. I'm not going to tell you that here. What I am going to tell you instead is to go to Glyph Lefkowitz's website, pip2014.com, which he set up about a day ago, which contains a shell script and a Mac app that you can use to set these things up for you correctly. It's really awesome. I recommend reading the shell script implementation. It's complicated and gets the edge cases right thanks to some user testing he did with me and some other people. So you can go there. This link will be at the end of the slides also. A lot of the problems I've talked about, therefore, come from compiled code that gets combined with Python code, so-called Python extensions. And wheels are one way to solve that. Another common way in the scientific community is a different package manager other than pip called Conda, which I just want to mention to make sure people know it exists. It has a really active user base in the scientific world, so consider using it. There's another way that you can use all these tools. PyPI-install is a program kind of like pip that instead of going and downloading things from pip, running setup.py, and putting them into your site packages directly, it'll do something very much like that, but it'll first make a .deb file, which if you're running Ubuntu or Debian, might be awesome. For me, it's totally awesome. I can use my package manager to find out which distributions from PyPI are responsible for which Python modules I've installed by just using my package manager search tools. Quick show of hands, how many people here run Debian and Ubuntu as their main workstation OS? Wow, OK, more than I thought. Humanity has hope still. You should all use PyPI-install. And you should use it now, because Paul Tagliamonte, who's sitting in the front row here, fixed it earlier today. It was broken due to a change in the python.org website, which has been fixed since. There's also a tool that was talked about at the conference in a different session called virtualenv, which will take a requirements.txt file, which is a long list of specific versions to install, and make a virtualenv that you can then install with a .deb file. So that's actually all I have for you. I'm happy to take some questions. I'll summarize, though. I hope you've seen that you can install software from the Python package index, the cheese shop. I hope you've seen how to distribute it, at least in the broad strokes, and you know how to find out more. The best place to find out more is packaging.python.org. Unless you just want to have things work out of the box. I mean, packaging.python.org is great. It tells you how things work. pip2014.com will help you install a pip and some shell configuration, or a Mac app if you use Macs, that will set it up for you with --user by default. You'll never have to type that again out of the box. Noah Kantrowitz, after this, is giving a much more detailed look at how Python packaging is going to be even better in the coming years. So thanks, and apologies to any pip maintainers I've offended.
Please join me in thanking Asheesh. Do we have any people that want to ask questions?
Not a question, but first of all, great talk. Thank you very much.
That's not what I was afraid you'd say something else, so thank you.
No. Just one thing that I find useful that you left out was pip -- system site packages.
virtualenv, double
Yes,
hyphen.
yeah, I'm sorry, yes,
Yeah.
right. So that allows you to create a virtualenv that uses some of the stuff that's apt-get installed or whatever your package manager happens to be, and then you can add stuff from the cheese shop into your virtualenv. So
Yeah, thank you for that suggestion. It's a totally useful thing. I maybe should add it to these slides so that people afterwards can see that. virtualenv has an option where it will let you use code that is installed system-wide. Uh-oh, it's Glyph. OK, go ahead.
That's the thanks I get for setting up a website at 2
Wait,
in the
Glyph,
morning?
thank you so much. Also, Glyph bought pip.works, which unfortunately is not ready yet, but will be available soon, as I understand. .works is apparently a top-level domain now.
Yeah, I originally wanted that to be the domain name, but there's an SSL certificate and everything. You can actually download that app and know that it's from me. One thing I wanted to actually point out, another suggestion that I think might be helpful is, since so many people in the Python community are involved in outreach and education, this was a fantastic talk on the internals of, or not necessarily the internals, but the workings of pip and setup tools and distutils and all those things, and it's great to know all that stuff. Many of you might be tempted when you're introducing new people to Python to explain all of this intricate, interesting detail. And having been present at many workshops and helped many people get Python set up, I would just caution you not to ever explain anything about any of this. The reason that I wrote the shell script that eventually became that domain was that it's hard enough to learn to program, and if we give people instructions, they should work, and they shouldn't have to know why, especially because all that's actually happening inside pip and setup tools and all of these things is it's downloading some code and putting it on their computers so that they can use it. And the so they can use it is all about the locations and the distributions and the packages and whatnot. So use this knowledge for good, and don't pass it on to people as the first thing they learn about Python, because it's very intimidating. So hopefully that's useful feedback.
Yeah, it's super useful. This domain is great. I've tested it on my Debian machine. Other people have tested it on Mac OS. Just to add to that, of course, I want to echo what Glyph said, that if you're running introductory workshops, that you can skip talking about this so that you talk about the things you actually want to talk about. I received some meta advice on a website recently that if you want to give advice to people, you probably want to find out. So there's sort of, this talk explains why you have to do things the way that the shell script recommends, that I recommend here. But explaining why isn't always the most useful thing. So thinking about it from the perspective of somebody new means you just shouldn't explain that. Go ahead, yeah, sorry.
Hi, I have a question. Like, I maintain some Python packages, and I have some trouble getting setup.py work everywhere and work right. For example, I don't want to include the long description, so I just read the README file. But of course, that breaks for some older version of setup tools or something. So, is there somewhere a definitive tool, a definitive guide how to write setup.py so it's bulletproof? Thank you.
So I don't know of a guide for how to write setup.py so it's bulletproof, but unless there is one? No? OK. But I will give you a few quick tips. One is never run setup.py directly unless you have to. So if you tell people to run pip install whatever dot or your thing, pip will run setup.py for you. And pip does some crazy magic so that even if you do from disutils.core import setup, it'll be like, haha, nope, I put the setup tool setup there instead. And this means that people don't need any particular version of setup tools on their systems. Pip will sort of make sure that happens correctly, I think. So.
Actually, it will still, if you have setup tools, but an older version, it will still use that, so it might break, so it might remove some of the files from the package. But that's beyond the scope. Thank you very much.
OK, I think we have time for one more question.
This is probably also getting a little bit beyond the scope, but does OpenHatcher, have you had any experience using PyenV, which is sort of the RBM of Python for managing different versions of Python and things like that?
So the question was about different versions of Python installed in your system, perhaps managed with PyenV. I don't have any experience with that. I sort of wince at the idea of multiple versions of Python installed on one machine. I know that other people, such as the person giving a talk right after mine, winces at the idea of not having multiple versions of Python on one machine. But I've just seen too many users confused by, I opened a new terminal and I couldn't import this thing. And the answer turns out to be that the version of Python they're running here is not the version of the Python they're running there. And why do I need to explain this? So where possible, I try really hard to never have to explain that by refusing to install more than one version of Python, by minimizing use of virtualenv, and by recommending pip install --user.
Once again, please join me in thanking Asheesh for a great talk.